All right, hello everyone. Today we're looking at scatter plots, okay? Which is just basically we're plotting some points and seeing what we can learn from it. All right? In today's objective, we're going to use scatter plots to try to make conclusions about some set of data. All right? We're going to graph it to see if we can help learn about what the data is telling us. The essential question, guys, how can we model the relationship between two variables? Okay? As a scatter plot, it just has points that show a relationship between two sets of data. All right? An example would be one person's weight versus their height. We can graph weight and height. It looks something like that. Okay, we do it on an XY plane. They call that a Cartesian coordinate system, that XY graph. Okay, just plot the points. As an example, this is a local ice cream shop. They keep track of how much ice cream they sell versus the noon temperature of each day. All right, their daily sales of ice cream versus what was the temperature at noon that day. All right, this is what they got. But then they graphed it. And they found out, yeah, I'll move this up a little. They found out, yeah, it's easy to see here, looking at this graph, that the warmer the weather is, it leads to more sales of ice cream. All right, the relationship, it's not perfect. The real world is not perfectly linear. All right, but we can kind of see the relationship here, okay? Guys, and from that, then, we can draw what's called a line of best fit, or sometimes they call it a trend line. Okay, we make a line so we can learn about what's the slope and what's the y-intercept of the line. All right, so we can make estimates and forecast. All right, when you draw the line, you all try to get as close to as possible to all the points and have as many points above the line as below the line. That's kind of what you try to do. And as an example, this is the rise in sea level. Okay, you can see it's getting higher as we go. All right, and then you can plot a line of best fit that goes right through the middle here and see that our sea levels are going up. Okay, this ends, what, 10 years ago. Imagine what they are now. Guys, there's two things, interpolation and extrapolation. All right, interpolation means we find some value that's inside our set of data points. In other words, after we plot it, and this is the ice cream shop again, we can say, well, what if the noon temperature is 21 degrees? We can estimate, go up here to the line, say we're going to estimate our sales for that day is going to be $480. You can kind of estimate that given the line. Okay, once you get a line of best fit, you can use it to help plan your business. Guys, also we have extrapolation, where we go outside our set of data and keep drawing the line up higher or down lower, again, outside our set of data, to try and see, well, if it's 29 degrees, and again, guys, this is Celsius, so as it gets hotter, we can say, well, our sales might be $740 if it got up to 29 degrees at noon. Guys, just be careful with extrapolation, because you're moving outside the set of data that you know, the parameters, the max and the min that you know of. Sometimes you go outside those parameters of the data that you have, and funny things start to happen that you don't know about, because you don't have data from that particular range yet. All right, so just be careful about that. Like it says here, extrapolation can lead to misleading results, because we're in uncharted territory, okay? Guys, a correlation is a very important concept here with scatter plots. Guys, if two sets of data, if they're strongly linked together, we say they have a high correlation. In other words, if the slope is relatively constant throughout, all right? A perfect positive correlation, it would be a perfect line going up like this. And a perfect negative correlation, the points would be in a perfect line coming down like that. All right, that's pretty rare in the real world. All right, guys. Usually what happens, you might have kind of a high positive correlation, or they're relatively linear. Or you might have a high negative correlation where, again, it looks relatively linear, but it's coming down. Or maybe kind of a low negative correlation. These points still do come down as x gets bigger, but it's not that close to a line. The same with the low positive correlation. I mean, clearly, as x gets bigger, the y coordinates also are getting bigger, but it's not a real high correlation. All right, and sometimes the points just go all over the place. All right, there's no correlation at all. All right, learn to recognize those. All right, guys, that's it. Go ahead and complete the homework check. Thanks.